Buttercup here, and today we're going to do physical and chemical changes. So we're going to be doing a fun experiment involving Skittles, so stick around. So what is physical change? What does that look like, right? So when you talk about physical changes, you're talking about matter itself, right? It's a change in the matter, but it's not changing it chemically. So if you take water and you freeze it, you get ice cubes, but is that still water? You betcha. So if you have a piece of wood and you burn it, is that still piece of wood still wood? No, right? It's turned into something else. It has been chemically changed. So that would make it a chemical change or a chemical reaction. So with that knowledge, let's go ahead and start with our experiment, and you tell me if it's going to be a physical or a chemical change. So for this experiment, you guys will need some Skittles, a plate, and some water. If you want this reaction to happen faster, you might have to heat up your water, but if not, regular tap water will do. So I went ahead and warmed up our water. I just put it in the microwave for about 2 minutes, so it's pretty warm. And then I also rearranged the Skittles so it can make a cool pattern once we pour the water onto our plate. So like I said, it's pretty warm, so I suspect that the reaction is going to happen pretty quickly. So let's see what that looks like. Like I mentioned previously, I had rearranged the Skittles in the way that I thought it would make a cool pattern. And then I'm going to go ahead and pour the hot water right in the center of the plate. And I'm not going to fill it all the way up. I'm just going to do it to where it's touching the bottom of the Skittle. So you guys ready? Let's begin. That was pretty awesome, am I right? So we saw that the candy was being discolored by the water, right? The hot water. So what do you think that is? Is that a physical or a chemical change? Did anything change chemically? So if you said, no, it did not change anything chemically, you are completely correct. It really didn't change anything chemically. The only thing that happened is that the Skittle was shedding its color due to the water, right? They were just mixing, but the water's still water and the Skittle was still Skittle, or the sugar is still sugar. Nothing happened when those two mixtures combined except created colored water. But at the end of the day, that can be undone. So if you guys said physical change, go ahead and give yourself a pat on the back because you passed. And until next week, bye!
Hi everyone, and welcome back to Bump's Place. Well, today we are going to be painting a model. Now, that's one of the things I like to do, is to build models, as you can see in my cabinet behind me. And today I'm starting to build a model of this Volkswagen Bug. Now, as I'm sitting here thinking about painting it, a question crosses my mind. And the question is this going to be a chemical change or is it going to be a physical change? That is the question that is to be answered today with the painting of this bug. Now, we have the shape of the bug. I have my paints here. I do have my helmet. I'm wearing my glasses. I'm in a well-ventilated area, but I'm wearing my mask also, just so I don't have to smell the painting. I shake up my paint, and I give it a little test on my cardboard here. Always make sure your table's covered. And I get my car in place. I painted the one side of the car, so we can answer the question, is this a chemical change or physical change. And looking at it, I did change the color of the car, but I didn't change anything else. The body of the car is still the same shape. It's still white underneath, but it's just blue on top. So, to answer today's question, it is a physical change, being that I have changed nothing else with the car other than the color. So, until next time, this is Bumps Place. Be safe and see you next time.
Hi everyone, it's Rubik's again, here to talk about chemical change today, chemical reactions. So we're going to be using pennies today to do our chemical change, and I just want to talk about pennies. Pennies are made from a copper, and so copper, as it's exposed to the air that we breathe, the oxygen, and as those oxygen molecules start to break down this copper, it's called copper oxide, which is what gives it sort of its rusty, tarnished, dull look, and kind of like a dirty look. And so after we use vinegar is an acid, and once we mix some salt with the vinegar, that compound mixed together is going to help remove some of that tarnished look from the pennies. Mine have been sitting in there for about 30 minutes, and once you rinse it off with water when it's finished, it sort of gives it that shiny, clean look again. So I'm going to show you the pennies that I have currently in here. So again, this is vinegar mixed with salt, and as you see those bubbles forming around the penny, that's because it's around the tarnished area that it's cleaning at the same time. And so after you're done letting it sit, the more tarnish it has on the penny, the longer you can let it sit. And then you can just watch the chemical reaction when you see the bubbles forming, and then you'll have all your clean pennies once again. So thanks again. I hope you guys learned something. I'll see you next time. Bye.
Hi, Plume here. The video you'll be watching is of chemical change. You'll see the wood as it burns and the ash that it turns into. Once it becomes ash, it has completely had a chemical change. Have fun! And now you see the wood burning as it has a chemical change happening. Here's our chemical change, guys. The wood is no longer a regular log. It has turned to ash, and it can't be returned back to a regular wood log, which makes it a chemical change.
I hope you guys enjoyed this week's video, and until next time, bye!